Good morning and welcome to today's presentation webinar from Frontier Precision. Today we're going to talk about best practices for accuracy when using Trimble total stations and the different targets that they have. The reason we decided to do today's webinar, I guess, is we're kind of at the height of construction staking season. There's a lot of different targets out there, whether it's the MT1000, the AT360, active targets or passive targets like a single Prism. And what we wanted to do is maybe give you a little bit of information regarding Trimble's recommendations on their proper use and what kind of accuracy you can achieve with them, as well as just based on our own internal testing what we recommend. So with that, I'm going to turn it over to Jay Haskamp, Applied Geodetic Engineer with Frontier. Before we do so, I just want to remind everybody that we will have the GoToWebinar chat window. So if you do have questions, just don't hesitate to chat them in. Just because it's a webinar, everybody's muted. We do have actually quite a few attendees. So chat your questions, just like we normally do in our webinars, as well as they will be recorded and provided later on this week on our blog. So look for that here later on this week. So if you want to pass this along to other colleagues and share it. With that, I'll go ahead and turn it over to Jay. There you go, Jay.
All right, thanks, Steve. Yeah, it looks like got a good number of people here, so that's good. So as he said, you should see in your little window, I think there's a chat window and there's a question window. If you have any questions, just put them in the question window because I believe we can then archive them. So if we run out of time, we can go back to them and reach out to you. We'll probably wait till the end to answer any questions, but at any time, feel free to put them in there. Hopefully everybody can hear me okay. A little under the weather today, a little nasally, so I apologize in advance, but we should be able to get through this no problem. So like Steve said, we're going to talk about best practices for accuracy with Trimble total stations and targets, and to kind of elaborate a little bit more, I guess, on what he was saying earlier. Is the first slide I have here is just why this webinar. So we feel it's, like you said, this time of year, it's an important topic to discuss. We continue to see some people struggling with just the proper use of the total stations, and we feel that if you're going to make the investment in one of those instruments, it's important that we help you. We do what we can to help you learn how to use it properly. So with that said, I guess I just have a few bullet points here that are kind of cover why we're doing this. So the first one is that technology advances very quickly, and it tends to make things nice and easy for us, but sometimes it can make things a little too easy. What I mean by that is a lot of times we can get just kind of in the groove and kind of get complacent with our surveying gear just kind of doing all the work for us. So it's really easy to just go out there and push buttons and get an answer, but what happens if something doesn't work or something doesn't check out or something goes wrong? What do we do? So we need to understand how these things work and how they operate so we can troubleshoot those problems. Also, we kind of ask the question, do we really know how to get the best results from our instruments? Do we just trust what it's telling us and hope that it's right? If something isn't checking right, is it because the instrument is wrong, or is it because maybe we didn't do something properly, we had a bad setting, things like that. So unfortunately, not all of us have the experience of working with theodolites and steel tapes back in the day and manually calculating things and all that kind of fun stuff. So maybe if we simply can just change our procedure a little bit on how we traverse or shoot in control or something like that, maybe we can get some better, more consistent results. And then also just sometimes it's the little things that can make a big difference, especially when using a total station. So we'll go into some of this stuff in more detail. So our agenda for today, kind of our topics that we're going to go through. The first one will be to just go over the different types of targets that we see people using the most out in the field. I want to talk about each one of them, what they do, what they're used for, things like that. And then we are going to go through just kind of a quick breakdown of the settings in Trimble Access. How do we add these targets? How do we set them up? How do we change them? Things like that. We'll give some examples of some common questions and issues, tech support calls and things like that that we get in regards to these targets and using total stations. We'll also provide you with some of our recommendations on just some of the proper use and procedures. I also want to go through some of the critical settings for total stations in Trimble Access that you need to be aware of. There are a lot of little nuances and things in there that can trip you up if you have something set wrong. And then lastly, I just want to briefly talk about the adjustments and collimations that you should be doing regularly on your robots. We're not going to go through the actual process of how to do them because we have a limited amount of time, but I do want to cover what they are and how you can do simple checks in the field to verify that if you need to do any of these adjustments. So first, let's just talk about the different types of targets that are being used. The first and probably the most common one is the Trimble MT1000, or what you might hear us call it the Multitrack. So this is basically a 360-degree active targeting prism. A couple things to make note here is it is rated to 5 seconds of accuracy. This thing can kind of throw a lot of people off not knowing this. So if you have a 1-second instrument and you're using a 5-second target, you're basically using a 5-second instrument. So keep that in mind first and foremost. Also, it's a powered prism, so we put a black GPS battery in here, the same type of battery we would use in like an R8. And then we have what we call 8 target ID settings. So if you can see my cursor here, hopefully, there's a little dial here where it says off on the bottom. We could turn that from off and then 1 through 8, and that sets our target ID, and I'll kind of break down a little bit more about what that means later. But when it's on and active, these little red diodes light up here, and the robot, when it's set to active tracking mode, will track those diodes as we move around. The next one we have is called the AT360. This is a 360-degree target. Note that there is no prisms on it. It's kind of got this reflective foil around it. So how this works is we power it up, and it utilizes the row of little diodes, LED lights here in the middle for our tracking, kind of our positioning. But then we also integrate like a DR type measurement in that's shooting this foil piece for our distance. So these are a little bit more accurate in terms of how they're rated. They're rated at 2 millimeters at 200 meters, about 656 feet. But keep in mind that that's a pretty short distance. Okay, so I'll go into this a little bit more, but these targets are designed for higher accuracy, but shorter distance measurements. You're not going to be pushing these out to 1,000 feet or something like that, which you may be doing with the MT1000. These also have 8 target ID settings, so you can see the little 8 little LED lights here that tell us which target ID we're on. And the other thing to keep in mind about this, unlike the Multitrack or the MT1000, is that this is an active target only. This only works in active mode. Whereas the MT1000, we can also, since it has prisms, we can operate it in passive mode. We also have a target in here that we like to call the R10. Actually, let me back up. I missed one point here. One other thing I want to talk to you about quickly with the AT360, sorry, is we can also Bluetooth this target to our controller. So those of you that are used to working with, say, the R10s where you have the electronic level bubble on your screen, we can Bluetooth this target to access, and we can also have the electronic bubble on the screen with this target in lieu of the pole bubble too. So I don't think a lot of people knew that. I just want to throw that point in there. But moving on to the next one, we call this one the R10 360. Some of you may have seen this one. This is a 360-degree passive-only prism. Again, it's rated to 5 seconds for accuracy. Note there's no power source, no batteries, no LEDs. So we can't run this in active tracking mode. It's a passive-only targeting system. So passive means that instead of tracking the target ID and the LEDs or the diodes, we're tracking just the glass, simply the prism part. These also come with a rod extension for offset prism poles, which I'll talk about in a little bit here. The next one is kind of the more traditional or old school, so to speak, version of the 360. We just call it a Trimble 360. It's a lot like the R10 360 where it's just a 360-degree prism, rated 5-second accuracy, no power source LEDs, passive only. It's the same type of setup. So this guy here and this guy here are pretty much the same thing. They just look a little bit different. And then lastly, we have what we call our standard style prisms. There's many different kinds of just typical standard prisms. I'm just going to kind of showcase the Seco versions because that's typically what we see, obviously being a Seco dealer. But these are single directional prisms. They're not 360-degree prisms. They come in many different shapes and sizes. They come in many different silver finish, copper finish. They come with different prism constants and things like that. So there's a lot of different types out there. These aren't powered. There's no LEDs. They're passive only. But they're standardized to basically work with all total stations. And if you do your research and dig through these, most of them are accurate to less than 5 seconds. You can get some very accurate standard style prisms. So I'll get kind of to it in a minute here, but if you're looking for more higher accuracy type work, we would still recommend these types of prisms or traversing prisms for really tight tolerances. All right, so going back to active targets, I just want to kind of break down how to properly use these targets, as there are some questions that pop up from time to time. So most of our robotic users are using some sort of active target. So first, both the MT1000 and the AT360 have target ID settings from 1 to 8, which I said earlier. So how this works is these numbers basically are going to correlate with whatever we set Trimble Access up for our target ID setting. And in order to track the target in active mode or have active targeting, the IDs in Access in our settings and the dial or the button that we have pushed on the actual target have to match. So this makes sure that your total station will only track that target when in active mode and nothing else. So in theory, we could have up to 8 of these targets on one site, and if they're all set on different numbers, they would not track each other. You would strictly stick to your target. Also, with active tracking, you're not going to see some of the issues that we see with passive tracking. So you're not going to see it, grab a window or a road sign or a tail light or something like that, or even a different target set to a different target ID. It'll strictly stay where it's supposed to be. In order for these to be on and active, we have to have a charged battery in them. So both of these two targets run off of the black lithium-ion batteries that we would put in, like an R8 style GPS receiver. One thing to be aware of, though, it's extremely important that you use only the Trimble branded batteries in these targets, especially in the MT1000. We've seen many instances where to save a little money, somebody will go buy the generic, the interstate type or the generic type aftermarket battery, and what will happen is the grooves won't be quite right or something like that, and they'll slide it in the MT1000. It'll work, and then when they try to pop it out to change batteries, the battery will be stuck and you can't get it out. So I can't stress enough, use the Trimble batteries in these targets to make sure you can get them in and out properly. When these targets have power, you'll see the LEDs light up red. As you can see in the picture, the MT1000 has 2 rows and the AT360 has just a single row, but they kind of accomplish the same thing. But when the battery runs out or there is a loss of power, the MT1000 can be used passively because it does have the prisms or the glasses on it. So you can use it both active and passive, where the AT360 has to be in active only. So if your battery runs out, you have to either switch to a different target or you have to get another battery to power it back up. A lot of people ask what the LEDs are for when they're in active mode. They're basically just for tracking and positioning to aim the instrument at the target. So they're kind of the most important component of the active tracking system. All right, so now I want to take a look at how to set these targets up in Access. So first thing we need is to be connected to an instrument. in order to get the little target icon on the right-hand screen. So to access the settings, we simply are just going to pick the little target icon on the right-hand side with our stylus, and then we're going to see a list of the current targets that we have stored in Access right here. If we want to add or edit, edit a current target, add an additional target, then we're going to take and we're going to tap on where it shows the target's rod height. If you tap on the actual target name, it's just going to change the type of target. So if you want to add or edit, you actually have to tap on where it displays the rod height. When you do that, it'll take you to the target settings screen. So the first box that we see highlighted here is where we're going to set our default target height. So knowing what this is going to depend on the type of target we use, the type of pole we're using, how high we want it to be, whatever. I'll get a little bit more in detail on some of the poles and things in a bit, but the value that you put in here is going to be the default height for that particular target. However, if you need to change it or adjust it at any time during the survey, you can do that right in the measure topo screen. The next box will be a drop-down list of the type of target that you're using, so you can see all the standard Trimble targets are listed here, as well as there's an option on the bottom for a custom target for a third party. For what we're going to do here, we're going to pick the Trimble Multitrack target, and then you can see it'll automatically display the Prism constant for that target. So if it's from the list and it knows what it is, we don't have to go through looking up specs and trying to find the constant. It'll know what that is and put it in there. So for the Multitrack, we've got a 10 millimeter constant. If you're using an active target like the Multitrack, you'll have a drop-down list, as you can see below, where we choose the target ID that we want to use. And then just make sure that whatever you pick here, you just turn your dial on your Multitrack to be the same number for them to communicate properly. So once we do that, I picked number 3 for my target ID. Then you may see, depending upon the target, you may see the type of tracking mode you want to set it to. You can see here we have passive, active, and semi-active. I'll talk about this in more detail in a little bit, but we would choose the one we want to use. And then the last option we have is to give it a name. So this is going to be something where you can easily identify it when you open the target list in General Survey. So once everything looks good, I'm going to name this one Multitrack. We just hit the accept button down on the lower right-hand corner of the screen to store the changes. Now, when we do that, we get brought back to General Survey. And again, we can tap on the target icon here. And what it'll do is it'll open up a list, and here you can see now the Multitrack. It's got the 1 behind it saying it's target number 1. It's got my rod height. It's got my Prism constant. It's got my target ID. So all of my information is now stored here. Now, if we want to edit this particular target, or we want to add an additional target, again, we just tap on the rod height for say, the Multitrack. And what we'll do is we'll be brought back to this screen again, which shows us the Multitrack settings. But maybe I don't want to change anything here. I want to add another target. So what I'm actually going to do now is hit the Add soft key at the bottom of the screen. And now I can set up a new target. So I'm going to set one up here for an Active Track 360. So first I got my, default rod height at the top. I pick my Active Track 360 from the list. You can see the little picture of it there. Prism constant is already entered in for me. I'm just going to use target ID 3. I'm going to track it in active mode. I'm going to call it AT360, and then I'm going to store it. And now you can see back in Access, I have both targets listed that I've just created. So the target that's currently used in Access is going to have a check mark in front of it. You can kind of see the little check mark in front of the AT360. My box is kind of covering it there. But you'll also see when this box is closed, it'll display the actual icon of the target that you chose on the screen. So when it's a Multitrack, you'll see the little Multitrack icon. When it's an AT360, you'll see the little AT360 icon. So you can kind of quickly just look at it and know which one it's grabbing or using at that time. To put in a custom prism or what we'd call like a 30 mil prism or something like that, just to go through a quick back in the screen, it's pretty easy. We have a rod height. We're going to set our prism type to custom. And now notice when we select custom, it doesn't automatically populate our prism constant. We have to manually key it in here. So this will be a 30 millimeter prism. We'll put that in. Then we can give it a name. I'm just going to call it Seco because I know it's my Seco prism. And then for a single glass prism, there's no target ID settings or anything like that. So we're going to leave that set to off, and then we can pick accept to store the new target. So pretty quick, easy way to set these targets up. Again, I have probably a little bit more detailed Tech Talk video on this on our survey blog. So if you have any questions on that or need to go back and review it, definitely go to the blog site and check it out. So if sorry, I lost my spot here. So anytime you do this, you might have questions. I just want to make a couple additional points about targets and access, just some kind of more general things. So the first thing to keep in mind is you can make up to 9 non-DR targets in access. So you can have up to 9 created targets. Also, when you're measuring rounds, for those of you that do this, be sure that when you set your rounds up that you select and change the proper target. So what I mean by that is if I have a 30 millimeter single glass prism for my back sight and I have, say, a multi-track for my foresight, make sure that when I am on my back sight, I select the right target. When I'm on my foresight, I select the right target. What is nice about that is when we do automated rounds, so we go through, we manually kind of build our rounds list, we select our proper targets for our initial measurements, and then when we have automated rounds checked on, the feature will not only automatically turn to measure our targets and points on its own, but it'll also know which target goes with which point. It'll automatically change those settings for you, so you don't have to stop it and keep doing that. It'll do it automatically. So it makes tying in control and traversing and things like that a lot easier. Also, to quickly change targets, if you're not a tap on the screen kind of person, you can use the Control P button on your keypad to change targets. And then you probably noticed there was a target DR option on the list. If you don't know what that is, it's just it stands for direct reflex, and that basically allows your total station to take measurements on surfaces that maybe you can't get to with a prism or a target. So maybe you have a connection point on a power pole or a window corner on a 3rd story floor or something like that. You can switch it to DR. You can manually aim to what you want to shoot and hit measure, and it'll take a measurement without a target. All right, so now let's move on to some common questions and issues that we see regarding the different targets. So first, we'll start with a couple of things that we've seen with the AT360. Again, just to keep in mind, the accuracy spec for the AT360 is certified to 200 meters, or about 650 feet. It's meant to be a short-range, accurate target. So don't push this out to 800-900 feet, 1,000 feet, and expect to be as accurate as you will at, say, 500 feet. So just keep in mind there are limitations to the distance to use that target. Also, we have seen some struggles with reflective surfaces behind the target. So again, you notice there's no glass on this particular target. It's got like a foil kind of band or a tape around it. So if you're standing directly behind it and you have the target relatively low and maybe you're wearing a safety vest with some reflective tape or striping on it, there are times where you may be confusing the gun as to what it's supposed to be shooting to. So with that said, there's a couple things to take note of. First is always get the target up higher so it's above your head. Even when you're, if you're running anything 360 and you're trying to get real-time directions, always run the target up above your head so the gun can always see it. Don't use it down at chest level, especially this target. This will keep it up above your vest. And then also, if you do have some reflective surface behind the target, say your vest or whatever, and it's having a hard time figuring out what is what, Access should give you a warning about there being multiple reflective surfaces and let you know that, hey, maybe I need to move out of the way or I need to raise the target up. So just be aware of that. Some things with the multi-track. First and foremost, probably one of the more common things we see are damaged or pushed in diodes. These can be problematic. So unfortunately, we see a lot of these MT1000s that get tipped over or they've been bumped and the diodes on them are pushed in. they're not broken, but they're just kind of pushed into the housing a little bit. This will typically cause inconsistency in your measurements when that diode is pointing at the gun. You'll especially see inconsistencies in the vertical. Another problem that we've seen is paint overspray. If you have overspray of your paint, maybe you're doing a lot of staking or something like that, and it's covering the glass or any of the diodes, again, make sure you find some Clorox wipes or some kind of wet wipes and clean it off. Get it nice and clean, because that'll also give you some inconsistent results. Another thing we've noticed is we're seeing people have some more success in terms of how they point the prism at the instrument. So if people are always pointing the same glass, let's say on the multi-track, to the gun, it seems to just be more consistent for them. You'll still have the 360 degrees for moving around and giving you directions when you're staking and things like that. But when you take a shot, if you stop and you point the same part of the target at the gun every time, you can ensure that you get more consistency because you're always looking at the same piece of glass and the same diodes. This is just one example of a customer of ours. They put this yellow stripe on the MT1000, and when they're ready to set up and actually initiate a measurement, they just make sure that the yellow stripe's always pointing at the gun, and it's been a lot more consistent for them. So just an idea, something to think about. All right, a little bit about prism pulls too. As trivial as this may sound, these have caused issues in the past. So first, it's important to know that the Trimble pulls are designed for the Trimble targets, not the standard single glass prism. So that you'll see graduations on the pole here, and you get a little pin to lock it in a specific height. Those offsets correlate to the height of the center of the prism. So they're not true measurements. They're offset for how tall that prism is. So when you put a Trimble prism on the pole, the graduation reflect the true height of the actual glass. There are third-party poles from Seco and CST and things like that that you can get that have graduations on them as well. But typically on those, the tips are adjustable for different types of prisms to compensate for different heights and offsets. The important takeaway from this is if you're unsure, always take a tape and check from the tip to the center of the glass to make sure you know what your rod height is. Don't just take it for granted that the pole is always going to be right. And another thing I've seen that I was just kind of thinking of this morning when I was going through this is I've seen many times where to save time, I'll see people put a GPS receiver on the Trimble robot pole. Keep in mind your GPS reference measurement is to the bottom of antenna mount. So if you throw that on there, you're not going to be at 5.5 or 5.4 feet or whatever that is. It's just not, it's not offset properly. So just keep that in mind that you need to know how those graduations work, and again, always measure to verify. Another pretty interesting topic, we can really go out into the weeds on some of this stuff, but we'll just touch on some of it briefly, is issues regarding accuracy in terms of using GPS drive control. We see a lot of struggles with this. There are a lot of things at play when using GPS drive control. Typically the issues are going to come from maybe incorrect project setup or some sort of procedure in the field. So the first question you need to ask yourself is if your job properties are set up to make that work. There's some nuances in there. I'll go through a few of them in a minute here, but that's first and foremost, is your job set up properly. You also need to know how accurate those GPS coordinates are. Okay, so it's pretty counterintuitive to use a total station because it's more accurate, but then base all those measurements off of inaccurate GPS coordinates. We see that happen once in a while. You need to make sure that you know before you start with your total station that your GPS coordinates are accurate. It's the only way your total station shots will also be accurate if you're basing them off of that information. If you still tied into a known benchmark, example would be, did you just dial into VRS, get logged in, throw an azimuth pair in the ground, set up on it and go? Or did you check your GPS into a known benchmark? Did you calibrate it if needed and then go? So there's a lot of things going in there. So you still need to make sure that you check something for every job if you want to be accurate. We've also seen issues relating to backsights, how long your backsight is and how does it compare to your foresights. Are you doing some really high tolerance work and you're shooting maybe a backsight of 100 feet, but then you're measuring out past 1,000 feet? So some things like that can be problematic as well. And then this one happens surprisingly quite a bit, is how does your backsight check out? So when you're doing a station setup, you should be reviewing that station setup every time before you store anything. I get a lot of job files sent to me saying, hey, we set up on the wrong point, or hey, we measured the wrong backsight. Can you fix it for me? I like to say most of the time, yes, we can, but depending upon how complex the project is and how much work was done off of an incorrect setup beyond that, sometimes we can't salvage it. Sometimes it just can't be fixed. So when you do the station setup, you will see how well that backsight checked out. You should be taking a look at that and making sure that it's right and fixing any errors before you store anything. This happens a lot, so just be wary of that. I believe in your survey style there's a view before storage checkbox. I always like to recommend having that on so I can see how everything looks before I hit the store button and make sure that it's right. So with that said, we get asked a lot of times, I guess, on what our recommendations are to use in the field. So this would just be kind of our quick breakdown of suggestions here. First, when you're staking, we would recommend using something like the AT360 for maybe short range staking where you maybe need a little higher accuracy. It's a good accurate target out to that 200 meter mark. If you need to do anything beyond that 200 meter mark, then we'd probably recommend going to the MT1000. The reason for that is because it does have 360 degrees of prisms to track, so you can walk around. You don't always have to be facing the gun, and you can get some real-time directions on where you need to go and not have to worry about stopping and shooting. So short range AT360, long range MT1000. I do want to throw a little note in here that for the best vertical results possible, again, it's going to depend on the conditions, but it's recommended to stay within 500 feet when using either one of these targets. If you're looking for vertical accuracy, keep your shots as short as you can. For some topography type surveying, recommendation would be using the MT1000. Especially in the woods. Typically topography, you have a little bit more leeway. You're not using such super tight tolerances as you would with, say, traversing or something like that. Plus you have the 360 degrees where you can just measure and not have to waste a lot of time facing the gun. And if you're in like the woods or some harsher areas, you have the active tracking to stay locked on to you and to not have a lot of issues with losing lock on your target. If you're traversing, this is where we would recommend going to some sort of a single glass prism or a traversing prism. This is because these are stationary, usually on a tripod or something like that, and they're usually a more accurate type of prism. And then for measuring or setting control, basically the same thing, as stated above. We'd recommend just the single glass or traversing prisms because they're just more accurate. Another thing I want to throw in here, though, if you're looking for some ability to try to get some very precise elevation information on your points, but don't want to pull out a level, maybe just still using your total station, we would recommend the Level Me module for access. I know some of you on this webinar, just looking at the names, are using this already. What it does is it allows you to basically use your total station to do some very precise trigonometric leveling, which, going back to the targets that we discussed, you obviously want to make sure you're using the proper prism when you're doing this. But with your total station, you can do your station setup, shoot your backsight, and then with that you can run level loops, level lines. You can shoot any side shots that you need, and then right in the module you can easily adjust them, and then all that information is just stored right in your job file. You can also export the data out in the DINI format or a CSV format for if maybe you're using some third-party adjustment application that these work in, or you can bring the DINI format into TBC and you can actually run the level editor on it right in TBC. So the module is a great tool for just kind of some on-the-fly leveling with the total station. Bring it into TBC and it works with all of your data, and you can just adjust everything pretty quick and easy. So we're pretty big proponent of that. It's a great little tool. All right, so I kind of teased this earlier about the tracking method. So let's talk a little bit about active versus passive versus semi-active. So first and foremost, we just need to understand the difference between active tracking and passive tracking. So active tracking is where the robot is tracking the actual LEDs and using the target ID to follow the target or the glass. It isn't actually tracking the prism itself. Passive tracking is where the instrument's actually tracking the glass or the prism. And because of this, when we're in passive mode, total stations can sometimes grab other reflective surfaces, whether it's a road sign, a tail light, a window, whatever. So there's definitely some benefits to both. My recommendation would actually be to use the semi-active mode when you're using your robot. This would be for like an MT1000 Prism. So when you're in semi-active mode, the robot's actually going to track the target and follow the target in active mode while you're moving around. So it's going to follow you and it's not going to grab something you don't want. Once you stop and you initiate the measurement command, the robot is going to switch to passive mode and then lock onto the glass. It should hit it every time because it's already on the glass in theory. So it's going to switch to passive mode. It's going to take the measurement, and then when the measurement is complete, it's going to switch back to active mode. We found this through some testing. Steve and I did some pretty extensive testing on this, trying to put branches in the way and doing all sorts of stuff at different distances, and we found this to be a lot more consistent, especially in the vertical results, just by simply using the semi-active mode. Also, as with everything, a little disclaimer, keep in mind that there are going to be circumstances where using active or passive alone may be more ideal. But the other thing to keep in mind here too is that the AT360 targets only work in active mode because there's no actual glass. So semi-active mode is really going to be mostly for like an MT1000 multi-track type application. Some total station settings in Trimble Access. This is a couple of quick things I guess I want to go into. I'm not going to dive very deep into this because they can tend to be whole subjects just on their own, but I at least want to touch on them and make you aware of them so you can follow up with us later or do a little research on them. The first thing is the coordinate system settings for your job. So are you using a predefined coordinate system? You would typically do this maybe if you're combining your GPS measurements with your total station data in the same job, or if you're going to do some sort of integrated surveying where you're using GPS and total station at the same time. The other thing is alternatively, are you using a scale factor only project? So this is something we're going to typically recommend when you're doing only total station work. Okay, so when you're doing just that, use scale factor only. You're working strictly with coordinates, and then it'll help kind of eliminate any potential projection issues that we might see in our project. With that said, going back to a known coordinate system, a hot topic is grid or ground. It seems like every time we do a seminar or every time we do a user group or something, this is always a hot topic. So if you're working in a predefined coordinate system, do you use grid coordinates or do you use ground coordinates? Well, I hate to tell you, but it depends on the coordinate system. It's not just a cookie cutter, yes this or no that. So again, you need to know the type of projection that you're using and how those projections work so you can make sure you're picking the right setting here and you're getting the right information. Another setting that's kind of forgotten about sometimes in Access is the sea level correction box, and this is in the COGO settings under your project properties. This relates to your total station measurements. So oftentimes we're asked if this should be checked or should it be unchecked. Again, this is going to depend on your projection settings. This is where things can get confusing. But just a quick tidbit, I see we got a lot of Minnesota people in here. If you're working in a Minnesota county coordinate system, for example, and then you're going to be combining GPS and total station measurements, you'll need this box to be unchecked. You don't want to apply this correction. If it's checked, if it is checked, and we kind of check the distances between our GPS shots and the distance between our total station shots, they're not going to match. If we're using maybe a state plane type system and maybe we're scaled to ground, then we would typically want this checked on. So it's going to vary depending upon the coordinate system and the project setup. So it's just important to know what this does and how it's used.
Hey Jay, can I make one note to that?
Yeah.
Just again, it's just the way the county coordinate systems have been projected to ground inside of Trimble Access for the people that are using the Minnesota county coordinate systems. We do have a procedure sheet on this. There are a few counties, I want to say 10 or 11, in the state that are transverse Mercator projections that you don't want to uncheck this sea level correction box. And we do have a document on outlining which of those counties that falls into. So anybody that is interested in that does not have that document, I know we've given it out to a lot of people in the past. Make sure after the webinar, just send myself or Jay an email and we'll shoot it over to you. But there are just a handful of counties in the state that this sea level correction unchecking that Jay mentioned before that it doesn't apply to. So we just want to also be careful with that. So I just want to make that note.
Yeah, that's a good point. There is a map too for Minnesota. There is a map on MnDOT's website that breaks down all the coordinate systems, and if you can't find it, let me know. I have the link saved. I can send that to you as well. Oops, let me pick my screen back here again. All right, so moving on. Another important part, I guess, of using the robots, Trimble robots, is to regularly do these field collimations. So what you can see on the screen here is this adjust instrument menu. The three that I have kind of boxed in here should be done regularly. I find a lot of people don't do these very often, and it's kind of troubling. But if you want to get the most out of your instrument and you want to get the most accuracy, it's important that you know how to do these. So because of their importance, I'm going to take a little time to just run through the checks to see how you can just kind of do a quick check in the field to see if your instrument is a little bit out of adjustment or needs one of these done, but we don't have the time to go through each one of them individually. So if you have additional questions on that after the fact, let us know. We also cover all of these. We actually make you do these in our training classes too, so a little shameless plug for training there. But the first one is a compensator calibration. So we use this to basically adjust the electronic level in the instrument. We suggest that you do this routinely to check and see if the electronic level needs to be calibrated. This should be done fairly often. Personally, I do this every time I set the instrument up. It might be overkill, but honestly, it only takes a couple of minutes and it checks out and I know I'm good. I know I'm taking that that potential error out of the equation. It's also, though, important that when you do this collimation, that you let the instrument warm up for about 3 minutes just to make sure that that compensator is properly warmed up. I should also note with this one and the other two, you never want to do these on a windy day. If you collimate or do these adjustments on a windy day, you're going to have issues. So make sure you got a nice calm day when you do these as well. But going back to the compensator calibration, how do we check the electronic level to see if we need to do it? It's actually pretty easy. The first thing we're going to do is we're going to level the instrument up, per the level bubble screen, either on the Phase 2 display or on Trimble Access on the screen. And then we want to make note of these sighting and trunnion values. Obviously, when we level these up, we try to get it, dialed in as close as we can. But make note of what those values are once we have it leveled up and it's settled down. And then simply all you do is you just turn the instrument with your hand manually 180 degrees. Now what we should see is once the instruments turn 180 degrees, it should still be level or close to, and the sighting and trunnion values should be the same but with different signs. So, excuse me, you can see here the sighting value is -6 seconds. Once it's turned, it's +8 seconds. So it's pretty close. It's within 2 seconds, and it's from a negative to a positive. If they are not close, or the signs are different or whatever, that's a good indication that you then need to do the compensator calibration. So back on that screen, we're going to pick it from the list. We're going to run through it. It's completely automated. It's really easy. And then we're going to go back and we're going to run through this procedure and check it one more time to make sure that it's gotten better. The next one is an optics check. Okay, so this is how we're going to check our manual aiming accuracy in a single face measurement. So what we're going to do is we're going to turn auto lock off, and we're going to manually aim the gun with the dials to the center of our glass or our target. Then once we have it manually aimed to the target, we're going to hit the change face button to make the instrument, flop the scope and turn 180 degrees. And then we're going to check and see if the crosshairs are still on the center of that target. And if they're not on the center of that target, if it's off quite a bit like we see here, then it's time to do the collimates. So step 3 would be collimating if needed. So this particular one is the collimation and trunnion axis tilt. This one's a little bit more involved. You got to do some manual sighting and some manual turning of the knobs on there, but it's not that hard to do. Make sure though, when you do this adjustment, that your target, or I should say your prism that you're measuring, is at least 100 meters from the instrument. It has to be out 100 meters or more for this to work. And then the last of the 3 I want to touch on, this one is another one you need to do fairly often, is checking the optical aiming versus the tracker aiming. So this is basically looking at the difference between aiming the gun manually on the target, which you see on the left, and then having the gun locked on automatically with auto lock, which you see on the right, to see how a couple of things, if it's compensating our angles and everything, but also if it's moving a lot or if it's still on the glass. So how do we check this? Well, the first one is going to be with the target, or I should say with auto lock disabled or off. We're going to manually aim to the target or the prism to the center of the glass. We're also going to want to go into our instrument functions and go into survey basic and make note of what our horizontal angle and our vertical angle values are. So we're going to take a picture with your phone or write these down or whatever, but we want to know what these are when we're manually centered on that target. Then we're going to go back in and we're going to turn auto lock on, and we're going to see where the crosshairs are aiming or where they jump to. Typically they're not going to stay centered on the glass. They're going to move a little bit. But more importantly, we also want to go back to survey basic and see if those angles have changed. If it's in adjustment and it's good, ideally we're going to stay still right on that glass, and these angles are not going to change, or maybe change by a second or something like that, but they're still going to compensate back very tight to where we were. Yeah, okay. I was going to make another point, but the other thing is when we do this collimation, so it's the third one on the bottom, it's called the auto lock collimation, but similar to the last one we did, this is also one where the prism has to be at least 100 meters out from the total station. So make sure it's out far enough. The other thing to keep in mind when you're doing these two is you want it to be fairly level with your instrument. You don't want to be shooting way uphill or way downhill. So 100 meters out, fairly flat in terms of elevation change. And then this is another one that you should also be doing fairly regularly. I believe the spec on this one is to do it for every 15 degrees of temperature change. That might be a little overkill for the type of climate that we're in, at least here in Minnesota. That could be several times a day. But this is something you should maybe do monthly or something like that, just to make sure that things are checking out okay. The other thing too with this is to be considered, within spec, is at 100 meters with auto lock on, those crosshairs should be somewhere on that glass. If it's not on the glass, then it's not good enough. And there might also be a point where you can no longer do these collimations by hand to get them back to where it needs to be. It might get where these things are going to get so far out of adjustment that they physically need to be opened up and some screws need to be turned. So this is why we still recommend every year getting your instruments in for a clean and cal. Again, if you want the most accuracy you can out of these things, get them in yearly, get them gone through. It's just like getting your oil changed on the car. It's a necessary evil that you need to take care of to make sure that you've invested a lot of money in these. Make sure that you're doing what you need to do to keep them going. All right, so that's kind of the bulk of my presentation. I just kind of want to throw a little summary out here, and we'll look at some questions. First thing is that the total stations are typically seen as being the more accurate solution versus using GPS. But you need to keep in mind that for this to be true, you need to make sure that you do a few things. You need to do your due diligence to make sure you're using the total station properly. You also need to know all of the details of your different targets and settings. Know when to use what target, know how to set it up properly, and know when to change settings as needed. You need to know your equipment and how it operates, how the proper workflows, the proper procedures, the proper coordinate system settings, things like that. You need to know how to use these things, especially when things go wrong. Use common sense in the field, okay, especially when you encounter issues. Check your backsite residuals before you store them, things like that. Make sure you're set up on the right point. Make sure you have the right coordinate system selected. Make sure you're in the right job, things like that. Collimate your instruments regularly. It's important, those three that I went through, it's important to do those checks routinely, especially on big staking jobs or things where you're setting control or you need to be accurate. It's important to do those checks, and if they're not quite what you feel comfortable with, run through the collimation and try to tighten them up a little bit. And lastly, again, just get proper training. These things aren't cheap to buy. Spend a little extra and get some training. Learn how to use it. We're happy to do a little 1 hour, 2 hour session with you. We're happy to have you come to a full day's worth of training class, but definitely make sure that you and all of your guys know how you're using these things properly. So that concludes, I guess, the presentation I have. I guess at this time we can open up to any questions. Feel free to type them into the question window. It looks like the ones that are in there have been answered already.
Yeah, I just answered a few, Jay, but
Okay.
we can read through them again and just make sure that we communicate to everybody if they don't see those come up.
Okay, so I'll just kind of read off what I'm seeing here. The first one was a question on level module relative accuracy. So Steve, I'm just going to read your answers, but it just says same relative accuracies your total station and prisms are capable of. So for the best accuracy, make sure you use the single or traverse prisms when using the module. Next question is the Level Me module an application we have to buy, or should it be included with the standard access program? The Level Me module is not a standard module with access like General Survey, so it is something you purchase to use. It's actually created by a company in Germany. It's not even necessarily created by Trimble, but it's in their package. You can get a 30-day trial, just like you could with roads or tunnels or any of the other modules. Next question is the semi-active mode. Does it take longer to take a shot with all the switching from mode to mode? No, we haven't seen anything. It's automated. I'm just kind of reading Steve's thing here too, but yeah, it doesn't seem like it takes any longer time to measure that we've seen. Next new question, here we go, is what about the gray box Trimble target ID? Yeah, I didn't really touch on that. With the standard 360 targets, the little black 360 degree target, you can get like these little gray RMTs are called, or target IDs. It's like a little gray box that kind of clips onto the rod extension, and it's powered, and you can kind of turn it on. There is a setting in there for that. I haven't used one of those in quite a while, but I know that you can pick that and switch it to like an active tracking mode, where I believe you can put that RMT number in there. Is that correct, Steve?
Yes, that's correct.
Okay, good. Okay, that's all that's in there for questions. I guess I'll give it another minute or two, but aside from that, I guess we appreciate everybody attending. It looks like the number of attendees held strong through the whole thing, so I didn't bore everybody to death, so hopefully that's a good thing. Oh, here we go. Another question. This is a good one. What type of tripod do you use? I'm actually glad you asked that. I should have put that in the presentation. Tripods. Make sure you're using a very good, very sturdy tripod. Okay, whether it's full-blown Trimble Trimax tripod, they're probably the best ones you can get, or just a really good like a wood fiberglass tripod, especially with the robotic instruments. There's parts moving around in there and things going on. You need to make sure you have a good sturdy tripod. One issue that we've seen a lot with say using a Trimble robot is using a Dutch Hill tripod. I don't want to bash Dutch Hill. They're a good, low-cost tripod, but the problem is when you put a Trimble robot on a Dutch Hill tripod, they're just not sturdy enough in terms of being able to handle vibration and, as a good wood fiberglass tripod. So what we see a lot of times, you put a robot on a Dutch Hill tripod, you turn it on, and you'll get like a tilt error or something like that, and it'll look like your robot's broken and it's not working right. You call in and you talk to me, the first thing I'll tell you is put it on a different tripod, and 9 times out of 10 it works. So tripods are key. So a good wood fiberglass tripod or a Trimax would be my recommendations. I'm not sure on the next question, the 606 can use with SPS
Yeah, I can take a
7.
stab at that. Assuming the 606, or meaning the 360 Prism.
Okay.
RMT that's used with the 5600 or the 600, Geonomy or 600s.
Okay.
That in active mode you would not be able to use, as far as I know, with the SPS 700 or even the Trimble S series total stations, but you could use it in passive mode. So you could use it as a 360 in passive mode, much like the Trimble R10 360 or the regular Trimble 360. You'd still have to set it up as a custom Prism, I do believe. I don't think there is a choice to choose that in your list. And when you do so, it should say on the Prism, the 606, that it's a 2mm offset or a negative 2mm. And I do want to point this out too in Trimble Axis. When you are using a Prism with a negative 2 or a negative 30mm offset, you want to put that in as a negative. You don't want to put in 30mm and assume that the software is going to subtract that from your offset measurements. You do want to put that in as a negative in Trimble Access, so hopefully that helps. But that's the best, to my knowledge, on the 606 Prisms. It'd be a passive mode, and it would just be the 360 part of the Prism and not the RMT.
Thanks, Steve. It looks like the last question there is, would I be able to rebroadcast this from a cruise? Yeah, so this was recorded. We're still recording, and then I'm hoping, I shouldn't say I'm hoping, by the end of the week, we'll have this up and available on our blog sites, on all of our different sites. So just kind of keep on the lookout for that. If you don't see any kind of notification or anything like that, feel free to just get in touch with us, and we can steer you towards the link or the right direction to go get it, but it should be up by the end of the week. Okay, well, it looks like that's all we've got, and it looks like we're 2 minutes early, so it was my lucky day here. So I appreciate it, everybody. Thanks for hanging in there. Thanks for attending today. And if you feel there was something we missed or you have any additional questions, certainly you can get a hold of us offline as well. But with that said, I just want to again say thank you and wish everybody a good day. We'll see you.
Thank you, Jerry.